Welcome back to Catalyst Grid, and my name is Kingsley Imufua, your host. This is episode 5, the final episode of our Risk and Value Mastery series, and in many ways, this is where everything we have built comes together. We have covered the foundations of risk, identification and analysis, response and monitoring, and value management principles. Now we are going to put all of it into practice through the lens of value engineering, the applied discipline of redesigning and optimizing specific project elements to improve the value equation without compromising required performance. This episode is practical, it is case study led, and by the end, you will have a clear, actionable framework for applying value engineering on your own projects, starting with your next project review. Chapter 1. What is value engineering and how does it differ from value management? Value management and value engineering are related but distinct. Value management is the overarching governance framework, the strategic discipline that asks, are we doing the right project in the right way for the right cost? It operates at the whole project level. Value engineering is the applied technical implementation of value thinking. It takes a specific design element, a structural system, and MEP configuration, a procurement approach, a material specification, and applies systematic analysis to ask, can we deliver the same function better, faster, or at lower whole life cost? Think of it this way. Value management sets the destination and the route. Value engineering optimizes the vehicle that gets you there. In practice, value engineering proposals, VE proposals, are generated during the creativity phase of a value management workshop, developed by the design and engineering team, and then evaluated against the project's agreed value criteria. The two disciplines work in sequence. You cannot have effective value engineering without the value management framework to guide it and govern its outputs. Chapter 2. The VE process, a step-by-step walkthrough. Let me walk you through the value engineering process step by step, using a realistic infrastructure example throughout. Our example, a data center construction project with a 100 megawatt IT load requirement. The current design specifies a conventional N+1 redundant UPS and generator configuration in a dedicated power hall structure. The capital cost for this element is estimated at £18 million. Step 1. Select the element for VE analysis. Selection should be based on cost significance, elements that represent a high proportion of project cost, and design flexibility, elements where the design is not yet fully frozen or committed. Step 2. Define the function. Using the FAST approach, we establish the basic function, protect its load from power interruption. The secondary functions include maintain voltage stability, ensure regulatory compliance, enable planned maintenance without downtime. Step 3. Cost the function. We conduct a function cost analysis, allocating the £18 million across the functions that the design element performs. We find that a significant portion of the cost is attributable to the dedicated power hall structure, not to the electrical equipment itself. Step 4. Generate alternatives. The VE team explores options. Could the UPS systems be distributed across the white space rather than centralized? Could a modular generator approach reduce the structural requirement? Could a different redundancy architecture, 2N for example, better serve the actual operational profile? Step 5. Evaluate alternatives against the value criteria. Capital cost, whole life cost, operational flexibility, risk, program, and sustainability. Each alternative is scored and ranked. Step 6. Develop the leading proposal into a full VE proposal with outline design, CAPEX comparison, OPEX comparison, program impact and risk assessment. Step 7. Present to the project board for decision. This is a governance decision, not a technical one. The project board weighs the value case against program risk, client requirements, and strategic constraints. Chapter 3. Cost-benefit analysis for VE proposals. A value engineering proposal is only as credible as its cost-benefit analysis, and a robust cost-benefit analysis for a VE proposal must look beyond the capital cost comparison to the full lifecycle picture. Let us build this out for our data center example. Current design capital cost, £18 million. VE alternative, distributed UPS with modular generators and no dedicated power hall, £12 million. Apparent capital saving, £6 million. But we need to interrogate the whole life picture. The distributed UPS architecture may require more maintenance interventions per year, adding, say, £300,000 annually in additional operational cost over a 25-year asset life. That is £7.5 million of additional OPEX over the life of the asset, which means the net present value of the VE proposal at a reasonable discount rate may actually be less attractive than the raw capital saving suggests. This is exactly why lifecycle cost analysis is non-negotiable in value engineering. Capital cost is the entry point to the conversation, not the conclusion. The informed decision requires a full NPV comparison across the relevant asset life, factoring in operational costs, maintenance cycles, energy consumption, end-of-life replacement, and decommissioning costs. Sustainability adds another dimension. A VE alternative that reduces embodied carbon in the structure or improves energy efficiency in operation may have a life cycle carbon value that needs to be quantified and included in the assessment, particularly as whole-life carbon reporting becomes increasingly embedded in public sector procurement and ESG frameworks. When your cost-benefit analysis includes CAPEX, OPEX, NPV, risk-adjusted cost, and life-cycle carbon, you have a value case that can stand up to board scrutiny, client challenge, and independent review. Chapter 4. Integrating Risk and Value, the Unified Framework. Here is the insight that ties this entire series together. Risk management and value management are not separate disciplines running in parallel. When they are properly integrated, they become a single, coherent project optimization framework, and the sum is genuinely greater than the parts. Consider how this integration works in practice. A risk in your register identifies significant uncertainty around a particular design solution, a ground improvement strategy, for example. That risk flags a potential cost and schedule exposure. A value engineering study of the same element explores alternative ground treatment approaches and discovers that a different methodology reduces both cost and geotechnical risk simultaneously. The VE proposal closes a risk and creates a value gain in a single decision. Or consider it from the other direction. A value management workshop generates a VE proposal to substitute a standard structural steel frame with a post-tensioned concrete alternative, saving £2 million in capital cost. Your risk analysis then reveals that the concrete alternative introduces a 4-week program delay in the critical path, with a schedule risk exposure that effectively eliminates the capital saving when converted to program cost. The integration of risk and value thinking prevents a decision that looks good in isolation but is damaging in context. To operate this framework effectively, your project governance needs 2 registers, a risk register and a value register, reviewed in tandem at every governance cycle. Your project controls team should be fluent in both. Your project board should be making decisions that consider risk and value impacts simultaneously, not sequentially. This is the discipline that the best project organizations operate at, and it is the standard we should all be aspiring to across our industry. chapter series finale, final recap, and call to action. And with that, we bring our Risk and Value Mastery series to a close. Let me leave you with the core message from each episode. 5 principles that, applied together, will fundamentally change the quality of your project outcomes. From episode 1, front-load your risk thinking. Risk exposure is highest when your knowledge is lowest. Invest early. It is always cheaper than investing late. From episode 2, risk identification is a team discipline. Use structured workshops, SWOT, PESTLE, and a properly formatted risk register with specific descriptions and named owners. From episode 3, risk response is where risk management earns its value. Specific, costed, time-bound mitigations, Monte Carlo simulation for program and cost certainty, and governance dashboards that keep risk visible throughout delivery. From episode 4, value equals function divided by cost. Value management is a strategic discipline using the FAST diagram, the SAVE job plan, and weighted value criteria to identify and evaluate genuine optimization opportunities. From episode 5, value engineering is the applied practice, taking specific design elements, applying systematic analysis, building credible cost-benefit cases across the full life cycle, and integrating risk and value thinking into a unified project optimization framework. If you apply even 2 or 3 of these principles consistently on your next project, you will deliver better outcomes. If you apply them all with the discipline and rigor this series has been about, you will be operating at the frontier of project management practice. That is what Catalyst Grid is here for. To raise the standard of project delivery thinking across our industry, one video, one framework, one project professional at a time. On behalf of the entire Catalyst Grid team, thank you for watching this series. I am Kingsley Aimufua, your host. Do not forget to subscribe, like, share, and comment. Your engagement is what drives us to keep creating content at this level. We will see you in the next series. Keep building, keep optimizing, and keep delivering value.